Hello and welcome to episode 5 of the Turing Complete walkthrough. We are finally in the programming stage, and I don't exactly remember most of these. I remember the maze the best. It's one I've completed most recently myself. But let's see what we got. You have built your own computer, but to win the competition, you still have to finish the maze. But since you don't know how to program it yet, you are not quite ready for that. So in the meantime, we will have you help out on this ship a little. Click on the edit memory icon on the program component to start programming your computer. Your computer should read an input, add 5 to it, and output it again. No need to worry about overflow. Notice that the immutable red register components have been replaced with a custom component with identical functionality. Alright, I don't know what relevance that has, but thank you. Alright, so add 5 to the output. I do remember that when I first did this myself, I accidentally created an infinite loop because that's what I thought it wanted. I didn't realize that it would just start over on its own. But anyway, check our instructions here. So first off, we need to move our camera so we can see our beautiful computer on the side. There we go. Okay. So we need to put, well, we need to save the 5 somewhere for doing easy arithmetic. So immediate, we'll put this value into register 0. So we can just put that in there. Now we need to move it out of register 0 because the ALU only uses register 1 and 2 for its arithmetic. So that will be copy register 0 into register, just put it into register 1. So copy register 1, oops. Alright, so that's the 5 taken care of that we'll just be reusing every time. Now we take the input and we'll put that into register 2. Copy register, or copy input register 2. Then we just call the add, and that will put the result into register 3. So now we just need to copy register 3 to the output. This is a pretty handy tool, I must say. Alright, I think that's it. Let's give it a run. Not too bad. Alright, calibrating laser cannons. On our ship, we naturally shoot incoming asteroids with lasers. In order to calibrate said laser, we want you to calculate the circumference of the asteroids using an advanced equation. 2 times pi times r. Yes, very, very advanced. R is the input, and you can approximate pi as 3. Send the answer to output when it has been calculated. Okay, well, we have 2 constants here, so we have 2 times pi, which is just 6. So let's go ahead and just save 6. So we can move the screen up there. Also, you now have access to assembly programming. It allows you to add names for instructions, so you can for example type add instead of inputting 68. All right, I'll show you that then first. Don't delete these. I'm gonna delete all of these. Just do it myself. Compute add. I like to use uppercase. Okay, now so this is also going to be pretty important. We're going to do our move command, or our copy command is just move, because that's actually a real assembly instruction, at least in nearly all assembly languages. But notice I'm not saying move register 0 to register 4 and adding a massive list of stuff over here. I'm just doing a copy and then leaving the rest blank. Now the way I can actually use this instruction in assembly is I can do move, and I can add the value of a register that I want to, well, first is the source. Let's say I wanted to use, I just want to pull a value from register 4, and I wanted to put it into register 2. Let's say I was doing some sort of math and I had to put it into a second register. Well, this would work if the assembler knew what register 4 was. But in binary, if we're just adding 4 plus 2, we're just putting a 6 in here. So we would be calling register 0 to output, but we don't want that. So how do we get this source register to be the correct value? Well, as it turns out, register 4 would look like just like that. But if it's the source register, it's 32. Say if it's the second register, then if you wanted to pull from it, it would be 16. So if you're noticing a pattern, the source register, the numerical value is always 8 times what just the register number is. So if we wanted to pull from 4, we just do 4 times 8, 32. Alright, let's write something useful. Alright, so I think the easier way to do this, alright, yeah, we're gonna just go put 6, 6, which is just that. You don't need a operation for just putting a value into register 0 because, you know, you got your immediate command here and just inputting the value. So we can just write 6. That'll put it into register 0. Move. Then the register we want to put it into. Because if you look here, again, if we wanted to move it from register 0, you're not actually calling any value here. It's just the copy instruction and then the destination register. So move plus, we'll put it into register 2. And then we'll move the input. I'll make an instruction for the input. Yeah. We'll just call this in. Let's move in to register 1. Okay, so now we need to add, well, really we don't even need the 6, because if we can just hard code this to add to itself 6 times, and that's essentially the same thing as multiplying by 6. So move in, input to register 1. We'll copy register 1 to register 2. Move 1 times 8 is 8 for the source register into register 2. Now we can. So when we add, we put the value into 32, and then we need or not 32, into register 2. Register 3, so I'm sorry. So we just bring it back and add again. So yeah. Move register 3, which would be 8, 16, 24, back into 2. I'm sorry. Did that. So this will be, we'll comment this. You comment with the pound, and then just write whatever you want. So first addition. Type that over, make it look nice. I didn't actually add. There we go. Move it back, add. Second, add. I use number notation to make it the same length. Just copy this. third add. Fourth add. I keep forgetting the pound. Then with that, we have our sixth and final add, and we can just move register 3 to output. I'll make a instruction for the output. Move register 3 to out. Alright, let's see if this works. Just go by step. So we move input to register 1 there. We copied it to register 2. We added, so that's 2 times the input. We move that back into register 2. Do it again, 3 times the input, 4 times the input, 5 times the input, or 6 times the input. We've gone 1 too many. Yeah, I'm not sure why my comments are off. Maybe it's cut like starting from 0 or something. I don't know. In either case, we're ending with 18, and then we move it to the output. All right, let's just give it a run. Nice. All right, let's try out the storage cracker. Actually, not the storage cracker. Let's just go right to left. Masking time. In this level, you are given a number as input, and you should return that number modulo 4 as a result. The challenge is that you only have 8 ticks to output the desired result. Note, you don't need to change your hardware, you just have to figure out the trick to do modulo 4 quickly. Well, I already know the trick, and I'll show it to you. So, we only really have addition, subtraction, and the logic operations to work with. You know, those are the not and, the and, not or. So they give us a series of numbers. Just say like 1 1 0 0 1 0 1 1, and we need to modulo 4 this. So what modulo 4 means is that you divide something and then you return the remainder. So like in our number system, 11 modulo 5 would return 1. Because, 5 goes perfectly into 10, and then there's just 1 remainder. But the trick here is that in binary, modulo 4 just means that you return these 2 bits. Because everything on this side is just divisible by 4. Because this digit here, this bit, represents a 4. This isn't any different in our decimal system. I think the example the game gives is 4,321 modulo 100 is just equal to 21, because 4,300 is just 100 fits into it perfectly. So the same thing applies in binary with modulo 4. So how do we go about just extracting these 2 bits? But essentially what we just do is we take the result of ANDing these 2 together. And you're always using just 3 in binary. So if we look at this, the truth table, 1 and 1, true, 1 and 1, true. And then since these are all zeros, these will all automatically be 0 as well. And so you've successfully extracted the 2 bits, and that'll work for any 2 values you have up here. Let's say 0, 1. Well, 1, 1 is 1, 0, 1, 0. There you go. So yeah, that's really all we need to do. So let's implement that in our software. Again, they have all this for some reason. Okay, so let's just put 3 into register 2. 2, yeah. Then we'll move the input to register 1. And then we just call AND. If we create the operation for it. There we go. So that'll put that into register 3, and then we just move register 3, 8, 16, 24 to the output. Let's watch this happen. So there's 3 in register 0, moving it to register 2, input to register 1. We AND them together, we get the 1 back, and then we send it out. Cool. It's a nice little trick just using the bits and logic gate. All right, storage cracker. You win this level when you output the correct passcode. No output will fail the level. Additionally, the input will be 1 after a guess that was too high and 0 otherwise. That's interesting. So we could use, we can increment by numbers greater than 1. Then once we get a 1, we just step backwards. Or we can even subtract our increment and then increment by 1 up, which would probably be easier. Let me... I know I didn't do this when I did it myself, but I'm kind of tempted to do it now. So yeah, I'm gonna take a minute to think about that, and I'll try to get back with an implementation. All right, we are back, and I have written the code. I don't need that. I'll go by and explain it. I'm pretty happy with it. We got it in 16, 17, 18, 19 bytes of memory, so not too bad. All right, so I'm just setting up a constant to access the register 3 whenever I want to pull a value out of it, which I do quite a bit in the program, as you can see how many times it's used. I'm putting 10 into register 2. I'll step through as I do this. See there, 10 is into register 2. Now I'm doing that because I'm using that 10 for incrementing. That's how much I go up every iteration. So I moved up by 10, and then I saved that value into register 1 because the next time when I add 10, I want to add 10 to the previous number. So this time the previous number is 10, the next time it will be 20, and I want to keep building on top of that, so I save it back into register 1. Then I send out the value that I just added up to, which is in register 3, so I just move that out. And then I take the input, and I move that into register 3 because that is where you run the conditions from, which I do in the next one. So this is a new thing I created. It stands for jump greater than 0. So it's just condition greater than 0. I don't believe I went over the concept of labels, but here we go. So it says second pass jump greater than 0. So if this number in the register 3 is greater than 0, then we will jump to the label specified here. In this case, it's second pass, so we would jump here if it was greater than 1, but it is not. And so we just ignore that line and move to the next one, which is jump first pass. And now jump is that always condition. So we just always jump. Essentially, that's just starting this loop back over if we don't go into this loop. So we start over, and yeah, this goes on for a while. I know what the first value is, so I'll let it get up to that spot. Okay, this is close enough. I think one more time. Okay, there we go. So it just sent 250 to the output, and now it got 1 as an input. That means that the combination was too high. So now the condition, it's greater than 0, so we're going to jump to the second pass. There we go. So we subtract. That just undoes the last addition that we did. So 250 was too much, so we just stepped back to 240. Then we move 240 into register 1 because now that's our new starting spot. And then we put 1 into register 2 because instead of going up by 10 every time, now we just go up 1 every time. So we had our found value, which was 240. We just increment it by 1. Save. Well, I try it. In this case, I try it first because that would save a clock operation rather than if we saved it and then tried it. If it was successful, then that was just a wasted operation. So we try it first, and then it fails, and so then we save it and start over. This loop adding 1 jump. The reason I'm not jumping back to the second pass is because I don't want to do this subtraction anymore. So I made it another loop, and yeah, that's where we increment 1. I'll just step through this until it works. We're at 247 now, 248. I think it's 249 is the answer. Yep, there we go. So it just worked. And so yeah, this is quite a lot faster than if you just increment 1 and then send it, increment 1, send it, which is what I did in the original, my original solution. So I'm gonna pop this up, start over, and just let it run, and you'll see how quickly it goes. Yeah, not too bad. I don't have a video to show of just a normal incrementing, so you'll just have to take my word for it. That was pretty good. All right, we got Spacial Invasion. Just a reference to the old Space Invaders. Blah, blah, blah. Shoot the space rat. So yeah, they just move down. But yeah, anyways, the strategy here, I found the best one anyway, to just shoot this crate in front of you. Need to be selected on the window. Shoot the crate in front of you, walk in front, and then just wait for the rats to get close enough to pass. I'll walk up just to show you. When they're right in front of you, you just take in this input, and then you shoot them. They just kind of feed down into you again, like a typewriter method, I suppose. So yeah, let's see if we can implement that. So we need our controls. All right, got shoot laser, enjoy the moments, that's just wait, and then move up, and really those are the only 3 we need. So let's go ahead and make some constants for our registers. We'll put 3, move into register. We'll use 2. We can't use 3 because that will be used for conditionals. So const, that is move up. Oops. Move up. 2 times 8 is 16. Leave a comment for that. even though our variable name is pretty self-explanatory. All right, next is enjoy the moment. So 4, move that. We'll just put that in register 4. Const weight. 4 times 8 is 32. Weight. We'll tab these out to make them nice. Then we'll just put 6 into register 6, so that would be fire. Well, register 5. 5 times 8 is 40. Fire. That needs to be a 4. 6 into register 5. All right. Now let's set up our 2 loops. We're gonna have the we'll need to set up first. We'll have to shoot. So move, fire, out, move up, out. We're not going to bother putting the move up into a constant and into a register, because that's just kind of a waste. So that's that one. So we're just going to put it 4 and then, oops, numlock or numpad turned off. So 4 and then move out. So it's just going to move it out after firing, and that'll save us just a little bit of RAM. Okay, let's do some comments. Move 3, or move, I'll call it move action to register 3. Move laser to register 5. Move up. Okay, now we can set up the loops. We'll do label waiting. All right, for the first one, for waiting, we would just do we're not going to start with a wait. We're going to start with a move input to register 3. And then we'll jump if that is greater than 0. We'll do shoot or firing. Jump greater than 0. Let's make that label. So this one, we can just start with a shoot. So move fire out. And then I think we just want to jump back to waiting. Yeah. Really, do we even need to loop then? Well, we'll see. So if it's not greater than 0, then we just wait. So we can move wait out, and then waiting jump. So back to the beginning. I think that's good. Let's try some iterations. So we're moving data into the registers. We'll get rid of that. Got our data there. We just shot the box. Now we're gonna, okay, we didn't move up. 4 is the move up, right? Oh no, 4 is just wait. So 3. And this is supposed to be, yeah, that's wait. So that's supposed to be 4. I will move that into register 4 then, since it's not being used anymore. We'll change, yeah, that's right. Okay, 4 going into register 4. Need to change that comment. Okay, 4 into register 4. 6 into register 5. shoot the box, move up. Now we're going into waiting. So we just got the input, which is 0. So that should be false, this firing, or the greater than 0 should be false. So we just skip it, move waiting to out, and then just iterate through. All right. Let's wait for these rats to get closer and see what happens when they cross in front of us. Okay, we wait, and now we take the input, which is greater than 0. So we should jump to firing. We fired. And then we jump back to waiting. We take the input back again. All right. Looking good. All right, the next is the maze, but this is the biggest one we've tackled so far, and I think it merits its own video. It's quite a doozy of an assembly program, and there's quite a lot I want to explain with it. So yeah, it'll probably be like a 20-minute video just on its own. So yeah, tune in next time to see the solution for that. Thank you for watching.